Bismillahirrahmanirrahim. Welcome to the first part of 20th lecture of Statistics and Probability Theory. In previous lecture, we have discussed normal distribution, in which we have discussed the probability density function of the normal distribution and how to convert it into standard normal distribution. Standard normal distribution has parameters mu and sigma. And mu is equal to 0 and sigma is equal to 1, and how to locate the area with the help of the table corresponding to the value of the random variable z. So these were the things we have discussed in previous lecture. We will continue with the topic normal distribution in this lecture too, using the normal curve in reverse. The normal probability density function, the bell-shaped curve, is amazingly useful for explaining random events. In this lesson, we show how to invert this function using a table. We reverse the process and begin with a known area or probability. In previous lecture, we were given the value of the random variable, and we locate the area between the mean and some specific value of z. But in this part, we will discuss how will we find out the value of the random variable z by using the known area or probability, and then we will determine the value of x by using that value of the z. As we know that this z is the standard normal variable, where x is the normal variable, x minus mu over sigma. By rearranging them, we will get x is equal to z into sigma plus mu. As we want to find out the value of x, we should know the value of mu and sigma plus this value z. Using the normal curve in reverse, given a normal distribution with mu is equal to 40 and sigma is equal to 6, find the value of x that has 45% of the area to the left. So if we say the 45% of the area to the left, it means if we draw the normal curve, which is like this, and here we will have the mean. So we know that total area below the mean is 0.5 and total area above the mean is also 0.5, and total area under the curve is 1, but we have to find the value of x that has 45% of the area to the left. So this is the situation in which we have the mean 40, and here we will have the value x below which is the 45% of the area. So if I locate it on the standard normal distribution curve, so this is the normal curve, and this one is the mean, which is 0, and as we know, total this area is 0.5, and we have to find out the value of x from where the 45% is to the left. So if we say that that particular value x is here, let us consider it should be z, as we are using the standard normal distribution curve. So as you know, this area is 45 already, and this 45 plus this particular this area could not be 0.45, so this would be not the case that Z should be located here. So Z should be somewhere here so that the 45% area will be at its left. So let me erase this and draw it again. This is the curve. And this one is the standard normal curve. Here mean is 0 as this total area is 0.5. So let's say here somewhere here is the point below which is 0.45 probability, and let's say this point or value of the random variable is Z1, and we have to find out this value Z1. So what we will do, we will use the probability and go to the table to locate that probability in the body of the table and find out the corresponding value of the random variable Z. As we know, this is 0.45 area, so this area will be as this total area beyond the mean 0 is 0.5 and this area is 0.45. So 0.5 minus 0.45 will be equal to 0.5. So this 0.05. So this area is 0.05. So what we will do, we'll go to the table and go to the body of the table in the reverse as we have gone in the previous lecture. So this is the table and we will go through the body. This is the body of the table and this area is 0.00, this is 0.0438 and this is 0.0478 and this is 0.0517. As we have the area 0.05, we sometimes we cannot find the exact value, so we will use the approximate value. This value is 0.0478 and this is 0.0517. So this one is more closer to 0.05 as compared to 0.0478. So this is the area or probability which we have located in the body of the table. So we will find out the corresponding value of the random variable Z. If we go in this way, this is 0.1 and in this way this is 0.03. So the value of the Z1 will be 0.13. So this is the reverse use of the standard normal table. So this value of Z1 is 0.13, but as you know, this is the axis for the random variable Z. This one is plus infinity, this one is minus infinity. So all the values beyond this value 0 should be negative and above this should be positive. So this should be minus 0.13. So the value of the random variable Z is minus 0.13. So by using Z1 is equal to X minus mu over sigma as z is minus 0.13 and x is unknown which we want to find, and mu is 40 as it is given in the statement of the question, and sigma is 6. By simplifying this, we will get 39.22, which is the point from its left is 45% of the area. So this particular point is 39.22. In part B, they are saying that find out the value of x that had 14% of the area to the right. If we draw it manually, 14% of the area to the right, this one is the right side, and this total area is 0.5, as this is 0.5, as we all know this, and they are saying that x is some value that at its right is the 14% of the area. So this is the situation, this is the mean, and this is the point x. Let's say this is some value of this random variable x. From its left is 14% of the area. So what we have to do by drawing this at standard normal curve, its mean is 0, and let's suppose this is z and this is 14% of the area. As this is the right side, this is 0.14. So you have to find out this particular value of the random variable z. But the problem is that the table is giving you the probability between mean and some specific value z. So you should know this particular area in order to go in the reverse process to locate the probability in the body of the table and find out the corresponding value of the random variable z. So this is 0.414, and as we know this all area above the mean is 0.5. So this would be 0.5 minus 0.14, which will be equal to 0.36, and so as this area is 0.36, we will go to the table and we will locate here 0.036. It should be somewhere here. So these two values are close to 0.036, and this value is more. So this is the area which is 0.036. We will go to the table and we will find out in body of the table which value is more closer. We will take this value 0.3529, and this one is corresponding to we'll go in this way, which is 1.0, and this one is 8. So here z will be 1.08. That will be 1.08, and it will be positive as it is at the right side of the mean 0. So it will be 1.08, and by substituting it in z is equal to x minus, as mean is 40, and sigma is 6. By simplifying it, we will get 46.48. The value of the random variable x at this point is 46.48.